Okay, so before I start today's video and the basic concepts, I would like to make you understand the difference between a system and difference between queue. See, queue means number of people waiting. If I talk about, these are 2, 3, 4, 5 people are there, then at a time, this one individual is been provided service. Like if he's standing in a counter and he's been served by this server, this executive is servicing him, then this individual customer is not a part of queue, right? This individual customer is a part of a service. He's been utilizing these services, and customer this four customer are a part of queue, right? And this individual is providing services, is been utilizing services, right? So when I talk about queue, I will not consider this individual. I will only talk about this 1, 2, 3 and 4, right? But when I talk about system, then system comprises of all people standing in queue as well an individual who has been utilizing the services. So this is the basic difference between a system and a queue. So when I talk about service system or service setup, I am talking about people standing in the queue and people who are utilizing the services. And when I talk about queue, that means people who are only standing, who are waiting to get their chance to avail the services, right? So this is a basic difference between queue and system. Now I've already solved this, right? So then there is no need for, and difficult for me to write. So I've already solved this. Now when a question comes that what is the average number of customers in the system? So system means this all, including this 1, this 2, this 3, this 4, this 5, including the people standing in the queue and the individual who has been availing the services, right? So what is the average number of customers in the system, which can be represented by LS, right? So LS is equals to utilization rate divided by ideal ratio, right? Utilization rate means R, which you have seen in the last video, that utilization rate is represented by lambda upon mu, and ideal ratio means probability that there are no customers, right? That which was represented by 1 minus lambda by mu, right? Which you have very much understood in the last video, at the end, the last part of the video which I posted earlier. So ideal ratio means probability that there are no customers, which is represented by 1 minus lambda by mu. Now I will divide lambda by mu by 1 minus lambda by mu, right? So then I am doing I am making the common denominator, so I am multiplying mu by 1 minus lambda, so mu minus lambda by mu, so I am getting the common denominator. Then this is a division sign. Now if I want to be multiply, then I have to inverse this reciprocal, so mu goes up and mu minus lambda comes down. So this lambda by mu multiply by mu upon mu minus lambda. This mu and this mu is get cancelled. So the formula which I am getting is lambda divided by mu minus lambda, right? So this is the formula. This is the final formula. So if in exam you receive a question which tells you to find the average number of customers standing, in the system, including queue and an individual who is a system means people standing in queue as well, someone who is availing the services, then this is the direct formula which you have to use. There is no need for you to explain this, right? This can be explained only when someone in paper asks you to derive this formula, right? If in exam comes that calculate the average number of customers which are in the system, then you know the arrival rate, you know the mu, then you have to keep the values, and mu means service rate, and you just have to keep the value and you will be getting the average number of customers in the system, which is represented by LS. Okay, this was the first setup. Now second setup, that average number of customers standing in the queue. So if the question comes that what are the average number of customers which are standing in the queue, then it is represented by LQ. Okay, so LQ represents that what are the number of customers standing in the queue. So LQ means LS minus utilization rate. This is what I am explaining, that how this formula has came, right? It may be possible that this all derivation of the formula may not come in your exam paper, but you must be aware of it just in case it comes, right? Now ls is represented as we have already derived what is the formula for ls. So ls is lambda mu minus lambda, and utilization rate can be derived by lambda by mu, which you already derived, which we have seen in the last video. Then what we are doing is we are getting the common denominator. So mu and mu minus lambda is the common denominator, so mu will be multiplied with lambda and mu minus lambda will be multiplied with lambda again. So mu lambda, now lambda is multiplied by mu minus lambda, so lambda mu plus lambda square. This both gets cancelled. So the final formula which you get for LQ is this: lambda square mu bracket mu minus lambda. This is the most important thing which you need to calculate. So when a question comes in paper that calculate the customer standing in the queue, then this is the formula which you have to use: lambda square mu bracket mu minus lambda, right? Now the fourth question can be average waiting time for a customer in the queue. That what is the average waiting time that a customer has to spend in queue, right? Not in system, please. This queue and system, don't get confused between queue and system. I am talking about that if a customer is standing 15 minutes in queue and it takes 10 minutes to avail the services, then the queue time is 15 minutes and total time in the system means time consumed in queue and time consumed to avail the services. So these two are very different. So when I talk about that what is the time customer is spending to stand in a queue, then it is represented by WQ, and the formula we'll get is average number of customers in queue upon arrival rate. So average number of customers in queue is represented by LQ and arrival rate is represented by lambda. Now LQ is we calculated the value of LQ, lambda square mu bracket mu minus lambda. So I will replace, I already have the value of LQ, I'll keep the value, divided by lambda. Then I want to convert this division time into multiplication, so I will reciprocal. Then 1 by lambda by 1 turns to 1 by lambda. Then this lambda square is lambda into lambda. So I have 1 lambda here, so I'll cut this lambda. So then this lambda upon mu bracket mu minus lambda. This is the formula which I got to calculate the average waiting time for our customers in queue. Okay. So when a question comes to you that calculate what is the average waiting time for a customer in a queue, then this is the formula which you have to use. There is no need to derive. Okay, I am repeating this again and again. Make sure that you must be aware of this last formula, right? In exam you have to write only when you have been asked to derive. Okay, the probability to ask the derivation is not much, but this is the final formula which you have to write, and I am showing you this so that you get a bit more clarity, right? Now average waiting time for a customer in the system. Now this is very, very important, that what is the time a customer is spending in system. Now system means time taken by him to avail the services plus the time taken by him standing in a queue. So if I explain you a bit more, give example that if you visit a barber shop, then you are waiting for 30 minutes in queue, then that is your waiting time in queue, and then 10 minutes it takes for a barber to avail the services, to give you the services for which you have visited the barber shop. Like if you have visited a barber shop to shave, then 30 minutes is the waiting time and 10 minutes to shave. So entire time spent by you to visit a barber shop is 40 minutes, right? 30 minutes of waiting time including 10 minutes of the time which is barber has taken to shave. So then it is a part of entire system, right? So how to calculate waiting time in the system is represented by WS. So average number of customers in the system upon average rate. So LS and lambda. This is arrival rate, arrival rate. So lambda. Now ls, you know, you have very well defined the value of ls. It is lambda mu minus lambda divided by lambda. Then because this is division sign, I want to multiply, so lambda by 1 will be reciprocal, will be like 1 by lambda. I'll cut this lambda, so I'll get the formula 1 by mu minus lambda. So this is the formula for which I will get the average an individual spends its time in a particular system, right? So this is how you come to know. So these formulas which I am discussed, they are very, very important. The average time taken by a customer in entire system, then the average waiting time an individual spends in a queue, then the average time customers, what are the number of customers in a queue and what are the number of customers in a system. So these are the formulas which you must be aware of. So I'll be sharing you the sums which will help you to solve using this all formulas. Okay, thank you.